Hello everyone, I'm Paul and today we're solving problem 2200. Find all k distant indices in an array. This is easy and here I will show you step by step how to solve this. We're given an integer array nums and two integers key and k. So let's say we get this. This is nums, the key is 9 and k is 1. First we need to keep track of the indices in which the value for the element equals to the key. So we have the key here and here, and I will put the indices up here. So we have the key at index 2 and at index 5. And now for the result we need to build an array with the indices in which the distance between the index and any index corresponding to a key is smaller or equal to k. Let's see what this means. Let's say we are at 0 and the distance between 0 and 2 is 2. And 2 is greater than k, so we can't add this to the result. We continue with 1 and the distance between 1 and 2 is 1. And 1 equals to k, so we can add this to the result. So we add 1 here. Next is 2, and the distance between 2 and 2 is 0, and 0 is smaller than k, so we can add this to the result. We add a 2 here. Next we have a 3, the distance here is 1, 1 equals to k, so we add 3 here. Next is 4, the difference between 4 and 5 is 1, which is equal to k, so we add 4 here. And this is important, we are far from the 2, the distance between 4 and 2 is 2, so this is greater than k, we are far from this, but we are close from this index, from index 5, which is also a key. And given that we are close enough to at least one key, meaning the difference between 4 and 5 is 1, and 1 equals to k, well, this means that we can add this to the result. That's why we add 4 here. Next is 5, so the difference between 5 and 5 is 0, which is smaller than k, so we add 5 here. Finally, we have a 6, the difference between 5 and 6 is 1, which equals to k, so we add 6 in the result, and we return this. So just to be clear, we need to return the list of all k distant indices sorted in increasing order, and these are all the k distant indices sorted in increasing order. So let's see how can we solve this. So the way to solve this will be pretty straightforward. We'll use a set, and this set will include the indices for which the element equals to the key. So we'll iterate this from left to right with an I pointer starting from index 0, and we know that the key is 9, so first we are checking this is the key, it's not, so we update I. Next is 4, and 4 is not the key, so we update I again. Next is 9, and 9 is the key, so we add the corresponding index for this key, meaning 2, here in the set. So now we have a 2 in the set. Next number is a 1, and 1 is not the key, so we continue. Next is 3, and 3 is not the key, so we continue. Next number is a 9, so here we have another key, meaning we need to add the corresponding index in the set. So we add a 5 here. Finally, we have a 5, and 5 is not the key. So these are the indices for our key. And now we will iterate this again from index 0, from left to right, and on the way we will fill our result, which is initially an empty array. So first we are at index 0, and every time we are checking if the difference between the current index and any of these values is smaller or equal to k. In this case we add the current index to the result. So here we have a 0, and we are iterating this from left to right, and we are checking the difference between 0 and 2 is 2. 2 is greater than k, so we continue. Next, the difference between 0 and 5 is 5. So given that 5 is greater than k, we continue, and this means we can't add 0 here. So we update the I pointer, and here we are at index 1. So now we are checking the difference between 1 and 2 is 1, and 1 equals to k. So we can add 1 here, and we break this loop, and we update I. Now we're here at index 2. So we are iterating this from left to right. First we grab the 2 and we check the difference between 2 and 2 is 0, and 0 is smaller than k. So we add the current index, meaning 2, to the result. We break this loop and we update I. Now we have a 3, so we are checking the difference between 3 and 2. It's 1, and 1 equals to k. So we break this loop here, we add 3 to the result, and we update I. Next is 4, and the difference between 4 and 2 is 2. The difference between 4 and 5 is 1. And this difference equals to k, so this means we can add this to the result. So we add 4 here, we update I. Now we are at index 5. The difference between 5 and 2 is 3. The difference between 5 and 5 is 0. And 0 is smaller than k. So we add 5 in the result. Finally, we are at index 6. The difference between 6 and 2 is 4, which is greater than k. So we need to continue with the 5, and the difference between 6 and 5 is 1. 1 equals to k. This means we can add this to the result. So we add 6 here, and we return this. Then complexity for this will be big O of n times m, where n is the length of this array and m is the amount of positions which correspond to the key. And space complexity will be big O of n, basically because of this array we need to return. So now let's go with the code, and hopefully you will get the idea. First, n equals the length of nums, and now we will call our set pos. This is for positions. This will be an empty set initially. And now for I in range n, if nums at I equals to the key, we need to add to the positions the current index. So now we have a set with all the positions corresponding to the key that we are given, so we can build the result. Finally, we will return the result. This is return, and here in between, for I in range n and for p in pos, meaning for every position. If the absolute difference between any position in which we have the key and the current position is smaller or equal to k, we can add to the result the current index, and we can break this loop. And finally, we return the result. So this is it. And now we'll try and submit this and see if it works. As you can see, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.